Imagine eating a meal at 35,000 feet in the sky, and the only thing between you and a mess is a tiny plastic fork weighing less than 3 grams. You snap it once, and it breaks like nothing. But here's what nobody tells you. That fragile little tool is engineered with precision down to microscopic levels. Millions are made every single hour across the world, moving faster than your eyes can track. And the journey it takes, from raw oil deep beneath the earth to your hand, is far more intense than you'd ever expect. What you're about to see will completely change how you look at something you throw away in seconds. Think about this. Every year, the world produces over 40 billion plastic forks, spoons, and knives. That's enough to circle the earth more than 200 times if laid end to end. Most people never think about how something so small can be made at such insane speed, with such extreme consistency. But inside massive factories, machines roar nonstop, melting, shaping, and ejecting thousands of identical pieces every minute. And this is where it gets truly extraordinary. Because before any of that happens, everything begins deep underground, in a place you'd never associate with your dinner table. We start in the oil fields of Saudi Arabia, the United States, and Russia, where crude oil is pulled from kilometers beneath the surface. Thick, black, and heavy, this raw material smells sharp and burns with deep intensity. A single barrel of crude can travel over 8,000 kilometers before it even begins its transformation. Tankers, pipelines, and refineries work around the clock, because without this first step, your plastic fork simply cannot exist. But what happens next inside the refinery surprised even experienced engineers. Inside the refinery, crude oil is heated to over 400 degrees Celsius, or 752 degrees Fahrenheit, in massive distillation towers. You can hear the roar of burners and feel the heat pressing against your skin. The oil separates into different fractions, and one of them, called naphtha, becomes a key ingredient for plastic. This naphtha is then cracked at temperatures exceeding 850 degrees Celsius, breaking molecules apart into ethylene and propylene gases. These invisible gases are the building blocks of polypropylene, the exact material used in most plastic cutlery. But here's the twist. Purity must exceed 99.9% or the final product fails. The purified gas travels into polymerization reactors, where pressure climbs to 30 bar and catalysts trigger a chemical chain reaction. Molecules snap together like microscopic Lego bricks, forming long plastic chains. Within minutes, these reactions produce solid polypropylene pellets, tiny white granules that look harmless, almost like rice. Each pellet weighs just a fraction of a gram, yet billions of them are produced daily. They're cooled, dried, and packed into massive sacks, ready to travel thousands of kilometers again. But this is where the real transformation begins. Now we step into the factory, the heart of the operation. The air smells faintly sweet, mixed with heated plastic. Machines hum constantly, never stopping. Workers pour polypropylene pellets into large hoppers that feed into injection molding machines. These machines heat the plastic to around 220 degrees Celsius, or 428 degrees Fahrenheit, turning solid pellets into thick molten liquid. The sound changes here. You hear a deep mechanical rhythm, like a heartbeat of steel. And what happens next happens in less than 10 seconds. The molten plastic is injected into steel molds at pressures exceeding 1,500 bar. That's over 21,000 psi. Imagine that force pushing material into every tiny detail of a fork's teeth. The molds are cooled instantly using water channels, dropping the temperature to below 50 degrees Celsius within seconds. You can hear the sharp hiss of cooling and the sudden click as the mold opens. And then perfectly shaped forks eject out, identical in every way, thousands per hour. No variation, no hesitation. But here's something most people never notice. The forks aren't fully finished yet. Tiny excess plastic, called flash, must be trimmed away. High-speed cutters slice through at speeds of 200 cuts per minute. Conveyor belts move constantly, carrying forks through inspection lines. The smell of warm plastic lingers, and the sound becomes a mix of slicing, clattering, and mechanical rhythm. One mistake here, and millions of units could be wasted. And yet, the system rarely fails. Now we enter the world of precision technology. Cameras powered by AI scan every single piece at speeds faster than human blinking. They detect defects as small as zero point 0.1 millimeters, warping, cracks, incomplete edges. If even one flaw appears, the system instantly rejects it. Rejection rates stay below 2%, which is astonishing at this scale. But here's where it gets interesting. Sometimes, human workers still outperform machines. Experienced inspectors can feel imperfections machines miss. Tiny differences in weight, texture, even flexibility. They pick up a fork, bend it slightly, and instantly know if something is off. That human instinct, built over years, still plays a critical role in a world dominated by automation. And this balance between machine perfection and human intuition keeps the entire system running flawlessly. But the scale of what happens next is almost unbelievable. Globally, plastic cutlery production exceeds 120 million units per day. China leads with nearly 40% of total output, followed by India, the United States, Indonesia, and Turkey. The market value surpasses $15 billion annually, employing over 1 million workers worldwide. 50 years ago, most cutlery was reusable, metal, wood, or ceramic. Today, convenience dominates. But here's the shocking part. A plastic fork used for 10 minutes can take over 400 years to break down. Did you know some factories produce over 1 million forks in a single shift? Or that a single injection mold can create 32 forks at once in just seconds? Or that recycled plastic now makes up nearly 20% of new cutlery production? The industry is evolving fast, with biodegradable alternatives entering the market, but the demand for traditional plastic still dominates, and it's not slowing down anytime soon. So the next time you pick up a plastic fork, think about the journey it took. Oil pulled from deep underground, refined under extreme heat, transformed at molecular levels, shaped by machines under crushing pressure, and inspected with both artificial intelligence and human touch. All of that for something you might use for just a few minutes. And yet, behind it lies one of the most complex manufacturing systems on Earth. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the Earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.